right, good morning. We have a couple things to do. Miss Wesley is out, and I'm hoping that I actually link up this video correctly because woof, that was jacked up yesterday. So, I'm gonna double check it this time. All right. Hopefully your morning is starting off well. This is the 5th. It's Friday. We made it. The bell ringer today is the inner planets are called terrestrial and are made of solid rock. The outer planets are called gaseous giants and are made of gas. So compare the densities of the inner and the outer planet. So the main thing you need to think about is solid rock versus gas. Which one is denser? So if I threw a solid rock at you, or if I threw a balloon at you, which one would be more dense? That's really how you need to think about this question. So go ahead and write your answer in the My Answer column. You can pause me if you need to. And then now maybe you push play, and I'll tell you the terrestrial, the inner planets, even though they're smaller, you can see them right here, they have more stuff packed into them. So they are more dense. The inner are more dense. The outer, made of mostly gas, those are going to be less dense. So write that in the class answer. Okay? Once you're done with that, so if you need to, pause me, and then I'm going to show you what you're doing next. So go ahead and X out of that. We need to finish our notes. So if you're not sure where our notes are, you go to Unit 2 Exosphere, Function and Formation of Other Celestial Bodies, and then it is, I'm going to pull this up to the top. It's right there. Click on that, open it up, and it'll look like this. You need to scroll down. We didn't get to, so yesterday we talked about how solar systems form. They're a ball of gas and dust, just like a star. Gravity starts pulling in on it, and you get a protostar in the middle. And then, just like if you threw a pizza dough up and you spun it, it would start to, because it's going to start spinning, the outer parts are going to flatten out. So then you have the star begins to fuse, and you can see leftover matter starts clumping up and getting into orbits. Then you have planetesimals, so the clumping continues until you have like baby planets floating around. Those baby planets are going to collide with each other until they make planets. All right, so the inner portion of the nebula creates the inner terrestrial, rocky and more dense planets. So inner portions, let's highlight that, make terrestrial planets which are rocky and more dense. That's something you do need to know. The outer portions create the Jovian or gas giants. So that's a vocab word you need to know. Jovian planets, the gas giants. Their moons and other celestial matter. So it's mostly gases, ices. Overall, the stuff out there is less dense. Our solar system has 8 major planets and 5 dwarf planets currently identified. So you all know Pluto. You might have heard of Ceres, and there's a couple more that I can't remember off the top of my head. So 8 major planets. You do want to memorize those. So the way I remember those, so you have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. So I remember it by thinking, my very excited mother just served us noodles. So each of those words, so my would be Mercury, very would be Venus, excited would be Earth, mother would be Mars, just Jupiter, served Saturn, us, Uranus, and Neptune is noodles. So it gives you the order by remembering a sentence, a weird sentence, okay? All right, and that's all for your notes, so you can get out of that. And then we need to go to this other thing that we didn't finish, the nebular theory and exoplanets. Hey, remember, Wednesday is our next test, so go ahead and open this. Boop doop doop doo. Ra-ta-ta-ta-ta-ta. File. I'm going to make a copy. You don't have to, because when you click on it, it automatically does what it needs to do. This is my third block. All right, okay. And I'm going to look for yesterday's warm-up. So you should probably go to your third didn't like that. Third nebula. Did I make a copy? Yeah, here we go. So you're going to want to get this open because on your version here, you're going to want to fill this part out with the pictures that you already did. This is why doing the warm-up yesterday was important, and why I got salty. And I apologize. That was really embarrassing. I'm sorry. Anyway, so I'm going to go ahead and I'm going to make this smaller so that I can just take one big screenshot. Okay, so Control Shift and then the box up at the top. I'm going to pull and drag what I want. You guys will need to copy to your clipboard. If I go over here and I click on that, I can just Control V and it'll put my picture. Maybe. Get out of here. Oh, man. There it is. It'll put mine right in there, and I'm going to make it so that it like fits over here. I'm going to make it bigger so that it takes up the space that was there before. Okay, so you're literally using your warm-up from before. You take a screenshot, you pop it into here. Okay, so now you have the correct order. You're going to go into your notes, which, did I keep those up? No, I did not. So, word to the wise, keep your notes up. Boop, 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 doo, doo. Go up. There they are. And you can literally go to our nebular theory. And where it says, hey, define nebular theory, you're going to copy paste this. It's a spinning cloud of gas and dust collecting to a star, planets, and other celestial objects. Control C. Let's Control Shift V. Boom. All right, what force causes the gas cloud to begin to pool together and become more dense? Well, you should know that it pools together because of gravity. And that's going to be the first step or stage. What is a protostar and where does it come from? That too, you should be able to get to your notes, from your notes. Oh, those are your old notes. So a protostar is a glowing ball of gas and dust that will become a star but isn't using yet. And that is the second stage. Second stage, the beginning of what process identifies the birth of a star from earlier protostar stage? This you should have memorized. It's up there too. Fusion of hydrogen into helium is going to start that, and that is stage 3. So remember, once that lights up, the gases get blown out, the lighter gases. So that's going to be the third stage. What is the name for the clumps forming in step 4? Those are your baby planets called planetesimals. Right? Baby planets. And you need to know that. All right, how do the inner planets differ from the outer planetesimals? Well, we know that the inner planets are denser and rockier Inner planets are denser and rockier, and the outer planets are lighter or less dense and have more gases involved. All right, what is the difference in their composition? Well, inner planets, rock, outer planets, gas giants. What happens in between the last two stages to change the early planetesimals into the 8 well-defined planets? The planetesimals run into each other, getting bigger and bigger until they are a planet. Boom. Oof. Sorry about that. Name the 4 inner terrestrial planets. So we have Mercury, Venus, Earth, Mars, when I look at this. The 4 outer ones are out here. So we have Jupiter, Saturn, Uranus, and Neptune. All right, which of the 2 group planets from question 9 is more dense? The inner planets, because they're made out of rock. We're saying this a lot, so it's probably going to be on your test. Just saying. You probably should know the inner planets are made out of rock. Why are the asteroids and comets of the Kuiper Belt so important to our understanding of the solar system and how it forms? So these guys out here are the objects and asteroids in the Kuiper Belt are important because they are planetesimals and early solar system objects that never became planets. So they're like a snapshot of what the beginning would have looked like. All right. So hopefully you get all this. You push submit. You get a whatever out of whatever, because I just gave you all the answers. And I would keep this out because we have an activity coming up when I get back that is going to be looking at the order of the planets. All right. So see you guys in a bit.